In this presentation, we're going to look at binary subtraction using the 2's complement approach. There's an alternative approach called the borrowing approach that we could also use, but in this presentation we look at 2's complement only. So what we're going to do is carry out the following binary subtraction: 1 1 0 0 0 0 minus 1 0 1 1 0. Decimal equivalent of that is 48 minus 22. Our answer should add up or become to 26. So moving on. So this is how we might formulate the problem if we were doing it from the borrowing approach. But we're not going to use the borrowing approach. What we're going to use is the 2's complement approach. So rather than perform a subtraction operation, what we're going to do is perform an addition operation, the addition being the 2's complement of the bottom number here. So we're going to get the 2's complement of this. How do we get the 2's complement? What we do is if we have a 0, we change it to 1. So we have a 1 here. And if we have a 1, we change it to 0. So we have a 0 here, a 1 here, and a 0 here. Now we're not finished there. What we also have to do is add a 1 onto that number there to get our 2's complement. So the 2's complement is actually 1 plus 1 is 0, carry the 1, 1, 0. So the 2's complement is the number down here at the bottom. I'm going to that number there. So this number here is the 2's complement, and I'm going to add that to the top number instead of performing the subtraction. There's a little thing we have to do at the end to make sure everything is consistent. So the two numbers I have circled in red, what we're going to do is add those two numbers together. So, very straightforward operation. Addition there. 0 plus 0, 1, 0, 1, 1, and 1. So that's the result of the binary addition, but we have to do something here. We have to get rid of the overflow bit. The bit, as in the digit on the left hand side, which is almost always going to be a 1, it is always going to be a 1, has to be discarded. We are actually going to discard that number. We call that the overflow bit. And the answer is the number that we have, the number that we've computed without the overflow bit. So this is actually our answer here. 1 1 0 1 0. And if you can check that is actually equal to 26. So that is the answer we were looking for, 26, 1 1 0 1 0. And so that's how we would do a 2's complement binary subtraction, and that ends our presentation.